Both are important. Both are important. Good morning. Good morning. Good morning, Usha. Okay. Yes. Today I will going to send you whatever the notes that I supposed to send it. I will send it today. Today afternoon I will send it. Good morning, Umahani. Okay. Yes. Good morning, Afra. Equation of continuity. Little bit difficult, all these concepts, but don't lose your confidence. Practice at home. It is mathematics concepts only. So therefore, it appears as little bit difficult. But you should not lose your confidence. You are supposed to understand the concepts, study well at home. Okay. Right. Equation of continuity. We know about the equation of continuity in first PUC and first year degree. First PUC and first year BSc also. There we have chosen like this. There is a tube. Okay. Hydrodynamics. How much is the volume of water enter here? Volume of water exit here. They are one and the same. Here, volume of water is equal to area of cross section into velocity. Here, area of cross section into velocity. As you are close down the pipe width is going to get decreased, velocity is going to get increased. The width of the pipe is more, velocity of the water, whatever it is flowing, liquid, whatever it is flowing, it is said to be less. Velocity, if you want to increase it, so close down the area of the cross section of the pipe. Therefore, the liquid, whatever it is coming out with a velocity is said to be more and more. So A into V is a constant. This is volume. V means it is a velocity. Here V is said to be, capital V is said to be the volume. Volume is equal to area of cross section into velocity. This is area of cross section. This is taken from your hydrodynamics. First PUC you have studied, and also in first year degree you have studied. This idea we had to extend in the case of electric charges. For the electric charges we had to extend. So therefore slightly difficult concept. So carefully understand, and you have to practice all these mathematical ideas. Today I will send all these notes, certainly. Okay, I will going to send it. So pick up all these concepts, take some sheets of paper, make your notes, and practice that notes several number of times before the examinations or before your internal assessment test. As soon as if you are coming to the offline classes, I will conduct the test. Okay, yes, get ready for the test now itself. Yes, conservation of charges. According to the conservation of charges, whatever the number of charges they are crossing over a closed surface is equal to the number of charges leaving that particular volume. That is the what is that? The principle of conservation of charges. So I will going to make use of the conservation of charges. Principle of conservation of charges I will going to make use. So what it states that the net charge crossing a surface bounded by a closed volume, if it is not zero, this is the bounded by some volume here, then through the cross-sectional area, whatever the charges are going to get passing, if it is not equal to zero, then I can say the rate of increase of charge is equal to the rate of decrease of charge. The rate of inflow of charges is equal to the rate of exit of charges. They are equal to each other. This is the equation of continuity or conservation of charges principle. This is a principle of conservation of charges. Again, I can repeat. There is a cross-sectional area, and the volume, it has been closed down here. Volume, there is a what is that? Maybe it is bounded by a volume. Cross-sectional area is there. If the net charge crossing over a cross-sectional area, if it is not zero, so the charges must be flowing. In that situation, the rate of increase of charges within that volume is equal to the rate of flow of charges within that volume. So how many number of charges are flowing inside, how many number of charges are leaving behind that volume, they are equal to each other. That is the principle of conservation of charges. I had to apply this idea for the charges I said. So this is conservation of charges, and let us derive the idea here now for about 5 marks. Derive the concepts. Now, we know already the total electric current is given by, I is equal to closed integral of J dot ds over a closed surface, where J is the current density, where J is called by the name the current density. J is current density. Derivation already started. I is equal to closed integration of surface, closed surface integral is equal to J dot ds. Okay, that is I is flows outside a closed surface. I is flowing outside, outward a closed surface. The total electric current is given by this formula. Now, but already we know about the concept here now, but I is equal to rate of flow of charges. The rate of flow of charges means dq by dt. Since the current is flowing outside here, I will put a negative sign. Charges are flowing outside. Therefore, I will put a negative sign. But again, I can consider here Q is equal to charges. Rate of flow of charges is current, but Q is equal to here integration of rho into dV, where rho is the density of charges over a volume. I will substitute this value here, then I will substitute that value here. Therefore, I is equal to, hoping that you are writing, I is equal to minus dq by dt minus d by dt of Q value is this, integration of rho into dV. Clear? Follow this. I is equal to this much. Now, this is also I. This is also I. Compare these two. If we are comparing these two here now, by comparing I and I, therefore right hand sides they must be equal to each other. Therefore, closed path yes J dot ds is equal to minus d by dt of integration of v rho dv. Okay, I can equate these two now. Therefore, we are going to get this. Right? So, therefore, this is equal to, further, that is equal to, I will take this one inside here, minus integration of over a volume integral d rho divided by dt. Just I have taken inside here. Slightly difficult concept. Only thing is you have to practice at home. Take some sheets of paper, write and practice. But easily you can secure the good marks here. Easily. Because complete mathematical concepts, if you are writing the mathematical concepts, you will get the whole full marks. Okay, full marks that we are supposed to give, no other way. Now we are going to make use of Gauss divergence theorem. Already finished now. Stokes theorem and Gauss theorem both are finished. And I said already, I will send you the notes today. So according to your Gauss divergence theorem, this is equal to this. I will use the Gauss divergence theorem here. From Gauss divergence theorem, let me use the Gauss divergence theorem. Using that, integration of S J dot ds, this one, can be written as surface integral. I will going to convert in the form of volume integral, that is Gauss theorem, Gauss divergence theorem. The Gauss divergence theorem, which gives an idea how to convert the surface integral in the form of a volume integral. So it is equal to volume integral of V del J here. This is a dot product. Okay, this is J, del dot J into dV. So a surface integral, it has been converted in the form of a volume integral here. Use this concept here. Okay, this one I will going to substitute this value here. This value must be substituting here. Here. See that whatever I have covered the things. Understand completely the derivation. I is the charges, I is the current, that is whatever it is flowing. Okay, since it is the charges are flowing out here now, it is gone decreasing here, therefore I have written negative sign. But Q is equal to integration of rho into dV. Substitute that. Now compare this I and this I. Compare these two. As you are comparing these two, this value is equal to this. Now for this one, for this, you have to use the Gauss divergence theorem. Using the Gauss divergence theorem, we got this. Substitute this one. This idea, I supposed to do the substitution. Another 4 or 5 steps, it will be finished. Okay, then I had to start Maxwell's field equations. They are very much important. Okay, yes. So whatever I have finished, I will continue with that concept here. J dot ds is there now. So J dot ds, integration of del dot J dV over a volume integral is equal to, how much we got it here, minus integration of d rho divided by dt into dV over a volume integral, of course. Both are volume integrals. Since both are volume integrals, I can remove the volume integrals on both the sides. dV also I can remove, volume integral also I can remove. Therefore, del dot J is equal to how much? Is equal to how much? Minus d rho divided by dt. Now take this one to the one side of equation. Write an expression like this: del dot J plus d rho divided by dt is equal to 0. This is called equation of continuity. This is a mathematical expression for the law of conservation of charges. So we can ask 2 marks question also. Write a mathematical expression for the equation of continuity or conservation of charges. The mathematical expression for the conservation of charges is equal to this. The mathematical expression for the conservation of charges is this: del dot J plus d rho divided by dt is equal to 0. This is the mathematical expression. When the charge is not moving, I will consider here, when the charge is not moving, if it is not at all moving here, if it is under rest, if the charges are not moving, then I can say d rho divided by dt is equal to 0. Therefore, this expression will be coming here. Del dot J is equal to 0. This is when the charges are said to be at rest here. When the charges are moving and the law of conservation of charges is holds good, this equation is holds good. Where I can say law of conservation of charges are holds good. That's all the derivation concept here for the equation of continuity. For the equation of continuity. Now, carefully, we have to take up one by one. Maxwell's field equations we have to derive. Okay, there are 4 Maxwell's field equations. Maxwell, he has derived the field equations by using your basic laws. You have already studied in your lower classes. That is, one is the Gauss theorem in electrostatics. Second PUC you have studied. Savard-Biot law in second PUC you have studied. Ampere's circuital law, second PUC, as well as in second degree previous class that you have studied. Faraday's laws of electromagnetic induction you have studied in your second PUC. Based on these 4 laws. So which are the 4 laws? One is Gauss theorem. The total electric outward flux is equal to 1 by epsilon naught times the total number of charges enclosed. You know already about these concepts. This is the Gauss law, and you know about the Savard-Biot law. The name of the 2 scientists, Savard and Biot law. The magnetic field. Sir, what if the charges are? I have not seen the question. Charges are not moving. Charges are not moving means the charges which are said to be at rest, current flow is equal to 0. If water is not flowing in a pipeline, if the water is not flowing, then I cannot say how much is the volume of water inside, volume of water goes outside. Volume of water going inside and volume of water going outside, it is meaningless. Because water, whatever it is said to be existing, it is a constant here to here, which is not moving. If the current is flowing, then only the charges are flowing. Charge flowing means it is a current flow. If the current is flowing means the charges are flowing. That is the meaning. Okay, for that one only we have derived the equation. Now, coming to the Maxwell's field equations here. Maxwell, he has derived the 4 equations by using the basic 4 laws. Which are the basic 4 laws? I said Gauss theorem. Using that, he has derived equation number 1. Using the Savard-Biot law, he has derived the second equation. And using Ampere's circuital law, you know about Ampere's circuital law. Using Ampere's circuital law, he has derived the equation number 3. Using this, he has derived the equation number 3. Okay. And using the Faraday law, using the Faraday law here, he has derived the 4th equation. These 3 equations are a little bit short, no problem, but the 4th equation a little bit lengthy. But all the 4 equations, derivations, all the 4, these are all called by the name Maxwell's equations. Maxwell's field equations. How many Maxwell's field equations? 4 Maxwell's field equations. We are asking these derive Maxwell's field equations. We are asking. Okay, we cannot ask all the 4. If we are asking all the 4, then we have to give 12 marks. So therefore, any 2 or maybe the 4th one or 2 and 3, 1 and 3, like that we are asking at the time of examination. Okay, using the Gauss theorem, he has derived the first Maxwell's field equation we are getting. Using the Savard-Biot law, we are getting the second Maxwell's field equation. Using the Ampere circuit law, we are going to get the third Maxwell's field equation. Using the Faraday's laws of electromagnetic induction, we are getting the fourth equation of Maxwell's field equations. All are very, very important concepts. Okay, which is the first one? Which is the first one? The first one is del dot D is equal to 0. Del is an operator, don't forget. D is equal to rho. Del dot D, del dot B is equal to 0. Okay, that is the second equation. Del dot B is equal to 0. B is the magnetic field. Where D is equal to, sir, what is the D if you are asking? D is equal to here, epsilon into E. You know about E, electric field, electric flux or electric field, field of lines. Epsilon is permittivity. Epsilon is equal to epsilon naught into epsilon r. Epsilon is equal to epsilon naught into epsilon r. E is the electric field or electric flux, electric field, electric line of force, electric field. Multiplied by this one is D. It is a type of electric field only with epsilon. If E is present, with epsilon naught is present, that is E only. With some other dielectric medium is present here, then it is D, nothing else. So this is the concept. Even in the case of B also, B is the magnetic field. B is the magnetic field. B is the magnetic field. Mu into H we are writing. B is equal to mu into H, where mu is a constant in that particular material, ferromagnetic material is constant. H is the externally applied magnetizing field. B is the magnetic induction, we are going to say. So this is the first equation we are supposed to derive. Derive. We are asking like this only, derive del dot D. Del dot D is equal to rho. Derive Maxwell's field equation. Del dot D is equal to rho. Del dot D is equal to rho. Maybe it carries 3 marks. Okay, what is that? Now we're going to consider Gauss theorem. I said already, I had to use the Gauss theorem here. So using the Gauss theorem, I suppose to write. What is that Gauss theorem? It states integration of mathematical equation that I am writing, taken from your second PUC, surface integral E dot ds. E dot ds is equal to 1 by epsilon naught times the charges enclosed. 1 by epsilon naught times the charges enclosed. Therefore, it is Q divided by epsilon. Where Q is equal to how much? If we are saying Q is, sir, what is that Q? Total number of charges enclosed in a surface. That is Gauss theorem. Total electric flux is equal to, in a surface, ds is equal to, now 1 by epsilon naught, the total number of charges enclosed. Where total number of charges enclosed is equal to how much? It is equal to volume integral of rho plus rho p into dV. What is this rho? Rho is the charge density. Rho is the charge density. Then what is that rho p here? Rho p is the polarization charge density. So take your second PUC one booklet. See that electric polarization is there in the case of capacitors. If you are keeping the capacitor plates here now, if you are applying the charges, so one side, another side, and in between the two electric plates here, if you are keeping a dielectric slab, what will happen to the polarization you are going to study? Already you have studied about the electric polarization. Polarization, I think interference, diffraction, polarization under the light energy already you have studied. But electric polarization you have studied in your PUC level itself. So that polarized density of charges, that is said to be rho p, and the charge density is equal to rho. If you are adding these two over a volume, that is equal to Q. Therefore, I will going to substitute that Q value here. Therefore, that is equal to 1 by epsilon naught times Q value is how much? Q value is integration of V over a volume V, rho plus rho P into dV. This is the first equation that I am deriving. Okay, rho plus rho P into dV. See that? But rho P is equal to here means polarization afterwards, whatever the density it has been present in the case of charges, called by the name the polarization charge density. Polarization charge density, that is equal to minus del dot P. Minus del dot P. I will substitute this value here. Therefore, that is equal to how much? 1 by epsilon naught times rho minus this. Okay, I will write in a next page here. I will write in a separate sheet. Observe that. I will continue. So that is equal to okay, you can see both the equations. That is equal to 1 by epsilon naught times integration of V, this is rho as it is, minus rho P value I will write del dot P. This dV as it is over a volume. Correct. This is your integration of what is that? Surface integral of E dot ds. Because afterwards we will forget about this. I will copy from here to here. Right. Now here volume integral is present. Here surface integral is present. We cannot equate now. Therefore, this surface integral I will convert in the form of a volume integral. Using what? Gauss divergence theorem. I will use Gauss divergence theorem. According to Gauss divergence theorem here, integration of surface integral of E dot ds is equal to how much? It is equal to integration of volume integral. Surface integral I want to convert in the form of volume integral. I am converting surface integral in the form of volume integral. E dot ds is equal to volume integral of here del dot E into volume dV. Substitute this value here. Therefore, integration of volume integral del dot E dV, just I am doing the substitution from here to here, is equal to 1 by epsilon naught volume integral rho minus del dot P into dV. Now we can equate now. Easily we can equate because both are volume integrals. Both are volume integrals. But after writing in the two equations here now, two expressions, then only we can equate. So this can be written as that is equal to epsilon naught I will borrow from here to here. It is there in the denominator. So I will shifting from here to here. Clear? This epsilon naught, I will multiply to here. Not for the operator. This is an operator. Don't say that epsilon naught into del you write. No. This is an operator. Just like your differentiation, I told you already. We cannot multiply with this. So we have to multiply with this. It is a constant. Epsilon naught is a constant. Therefore, I can write integration of V del dot epsilon naught into E into dV. Okay. Right. This epsilon naught I have taken here is equal to remaining thing here, integration of here you write the next step. Hello. So what you are going to get? Epsilon naught into E. So it is equal to how much? Rho into dV volume, rho into dV into volume, minus integration of this volume. Just this particular one you split into two equations, nothing else, two expressions. Okay, rho into dV I have written, minus as it is, integration as it is, volume del dot P. Easy. Only thing is you have to do the practice at home. dV. Clear? Now I will shift this negative sign. Anyhow, it is said to be volume and volume. I can add these two. Therefore, integration of volume integral del dot epsilon naught into E coming over here plus del dot P into dV is equal to how much? Integration of volume integral here rho dV. Here del operator is present in both the sides, here as well as here. So one del operator if we are writing together is enough. So therefore volume integral del dot epsilon naught E plus P whole thing dV as it is, integration of rho dV. Clear? But epsilon naught E plus this P is called by the name capital D. That is D is epsilon naught into capital E plus this polarized. Plus polarized charges are also there. Together is said to be D. Substitute this idea here. Therefore, integration of del dot, this value is equal to D here. This is volume is equal to integration of volume integral rho dV. Here volume, integration, dV, you remove all those concepts. Then the remaining here, del dot D. Del dot D is equal to rho. This is called by the name first Maxwell's field equation. If you are not present and if you don't work it at home, once or twice if you are writing, you cannot write at the time of examinations. Hundreds together time, if you are practicing at home, then I'm sure you will get a question from here. Certainly. It's not only these 4 equations. Still we have to write like this so many other equations. Don't forget. In your most probably second degree, you have studied about the thermodynamic potentials now. Thermodynamic potentials, TDS equations. Okay, there also you are going to get the differentiation concept. Here it is a del operator system. We are using the del operators here. And after 2 years, if you are going to the MSc level, without these ideas, we cannot. One paper will be there, electrodynamics only. Okay. On paper, electrodynamics means you have to study all these concepts. If you don't know these ideas now itself, then there it will be very difficult. And moreover, it is easy to score the marks here. Only the thing is, we require some practice sessions. Take some sheets of paper, write and practice. Easily we can secure the good marks here. But a student who has not studied properly these ideas, okay, there is a probability of securing even 0 also there. If you are worked out properly, on the other hand, you will get 100% here. 100% marks you will get it. Here we are not going to reduce the mark at all. If you are writing all these concepts, certainly we have to give the full mark. Certainly. Because here there is no explanation, only mathematical steps. Only the mathematical steps are present. But little bit higher class mathematics, not your lower class mathematics. We have to learn. Okay, if the time permits, again I will show it all these concepts again. Okay, that's right. Second equation, number 2. Maxwell's second equation, derive del dot B is equal to 0. Del dot B is equal to 0. Now we are going to make use of Savard-Biot law here. From Savard-Biot law or Biot-Savard law, no problem. Savard-Biot law. Magnetic field, whatever it is, produces due to a current carrying wire. The magnetic field produces due to a current carrying conductor is given by mu naught divided by 4 pi. It is there in second PUC. Okay, mu naught divided by 4 pi. IDL sin theta divided by r square. Then using that one, if you are writing any expression in the form of a vector format, then you are going to have I integration of dl. It is a current element, dl is a current element, cross R divided by R cube, where R is the distance. If there is a current carrying wire, if you require a magnetic field here now, this is a current carrying wire. Here, if you require a magnetic field, the perpendicular distance between the current carrying wire to the point here, this perpendicular distance is R. This is a position vector, called by the name the position vector, from the line element dl to the point under consideration, where we have measured the magnetic field. We have measured the magnetic field. First one for the electric field, second one for the magnetic field. This is for the magnetic field. Equation we are deriving for the magnetic field. Now we are going to consider the divergence here. Okay, this is the concept, we got it here now. This is we are supposed to derive. This one we have to prove it. We have to derive this equation using this. I will take the divergence here now. Taking divergence on both the sides. Therefore, here del dot B is equal to mu naught divided by 4 pi I integration of del dot B I have chosen. Therefore, I supposed to consider here del dot, here also dot. This is dl cross R divided by R cube. We are having a formula about this operator formula. It says that del dot A cross B is equal to, how to write that formula, is equal to B dot del cross A apply this formula here, del cross A minus A dot del cross B. Apply this one to here. I said I will write, if you want I will write del dot dl cross R divided by R cube. So here A is dl, B is equal to this. A is equal to dl, B is equal to this. So here B is equal to, here it is R divided by R cube dot del cross dl, because A is equal to dl, minus A is equal to, here it is dl dot del cross B is equal to R divided by R cube. R divided by R cube. Here, this is a current element. This is a current element. It is not a function of coordinates. This is not a function of coordinate. dl is a current element, means a wire, if it is present like this, if it is a wire is present like this, a small length of the wire, I can take that one as dl. Therefore, this value, whatever we have written here now, this value is equal to 0. Del dot dl is equal to 0. Del, of course, del cross dl, I'm sorry, del cross dl is equal to 0. Because dl is a current element which is not a function of coordinates at a particular point. Therefore, del cross dl is equal to 0. Therefore, this value is equal to how much? This value. Substitute all these things in that. So therefore, del dot B is equal to mu naught divided by 4 pi into I multiplied by this value is equal to this, whereas this is equal to 0. Remaining thing is this minus dl dot del cross r divided by r cube, this much. But this r divided by r cube can be written as r divided by r cube can be written as minus del of 1 by r. If you are taking the del operator for this, you are going to get r divided by r cube. Substitute these ideas here. Del dot b is equal to, okay, apply this idea. This value here, if you are putting, you will get a negative sign. That negative into negative is equal to positive here. Follow this, you will get positive value only. Mu naught divided by 4 pi I dl as it is, I can write del cross this value. Okay. So, but what happened to this negative sign here? One more negative sign here. If you are putting this negative sign here, minus into minus, minus into minus will be coming plus. But del cross del of 1 by r is equal to 0. This value is equal to 0. If it is equal to 0 here, 0 into anything is 0. Therefore, I can write del dot b is equal to 0. This is second Maxwell's field equation. Whatever I have derived so far, I will show it. Another 5 minutes time is there. Equation of continuity. This is the first derivation. Practice at home several number of times. These mathematical steps you have to write and practice. Okay. Continuation. Today, whatever I have covered, that I am showing. Next, Maxwell's field equations we have to derive using the 4 basic laws here. Maxwell's, he has derived the first equation, second and third and fourth equation. He has derived based on this the basic concepts. These two are finished. Next class I have to finish these two. I'm supposed to cover these two ideas. Derive first Maxwell's field equation. All are important. You cannot leave it. Even at the time of examination, you can write all these things like this only. Arrow mark also you can write it, no problem. What you are doing, you can show it, no problem. We don't want your, what is that, a good amount of neatness, not necessary. We want good mathematics. A good mathematical approach we require. This was first Maxwell's field equation. Okay, second Maxwell's field equation. Easy, only thing is you require the practice. Okay. Yes, right. Any doubt if you are getting, you can ask. But only thing is, read well at home.